Imagine a frozen traveler, older than our sun, racing through the void at unimaginable speed, a visitor from another star system, lighting up our skies for just a fleeting moment before vanishing. Forever, that's Comet 3 I Atlas, a cosmic messenger whose rapid brightening stunned scientists and astronomers around the world. For billions of years, it wandered alone in interstellar darkness, and then it crossed paths with us. A brief spark in time, a reminder that even in the cold emptiness of space, there are wonders waiting to be found, messages written in starlight, waiting for eyes brave enough to see them. As revelation wasn't just about science, it was about connection, curiosity, and the timeless human hunger to know what lies beyond. Every comet, every discovery, every flicker of light tells us something about who we are and where we come from. So if you believe in the magic of the unknown, in the beauty of cosmic mystery, hit that subscribe button. Join us as we explore the universe, one discovery at a time, because the sky isn't silent, it's speaking. And every star, every comet, every light is a story waiting to be told. In the vast silence of space, where light travels for billions of years and time itself seems to stretch beyond meaning, something small and seemingly insignificant began its journey toward us. It was not born in our solar system. It did not belong to the planets, nor to the frozen belt of comets orbiting beyond Neptune. It came from somewhere far away, a place no human telescope had ever seen, a realm of another star, another world. And yet, against all odds, it found its way here. NASA would later name it Comet 3 I Atlas, the third confirmed interstellar visitor to ever be detected in human history. The story begins in the quiet routine of scientific observation, a night like any other at one of the sky monitoring stations scanning the heavens. The Atlas Asteroid Terrestrial Impact Last Alert System Telescope in Hawaii, a project designed to detect hazardous asteroids that could threaten Earth, picked up a faint streak of light. It wasn't bright, nor did it seem unusual at first, but when astronomers compared its position from one night to the next, they noticed something strange. The object wasn't moving like a regular comet bound to our sun. Its trajectory was odd, hyperbolic, meaning it was not orbiting the sun, but simply passing by. That single discovery sent ripples across the scientific community. A hyperbolic orbit meant only one thing: the object was not from here. It was interstellar, and in the language of the cosmos, that word carries weight. It means a traveler from another solar system, a messenger from the unknown. At first, the object was catalogued as faint and unremarkable. It appeared to be a small comet, possibly a fragment of ice and dust only a few hundred meters across. But what made it so special was its speed and direction. It was moving faster than any regular solar comet could, cutting through the void at nearly 110,000 miles per hour, slicing across the sun's gravitational field like a ship barely grazing a whirlpool. The sun's pull couldn't capture it. It would swing by once and disappear forever, never to return. NASA and observatories around the world immediately began tracking it. The excitement was electric. Humanity had only ever encountered two other interstellar objects before: Oumuamua in 2017, a mysterious cigar-shaped rock that showed no tail, and 2I/Borisov in 2019, a more typical comet with a distinctly foreign composition. Now, in 2024, another had arrived, 3I Atlas, and scientists knew they had only a small window of time to study it before it faded into the blackness once more. Every night, as data streamed in from telescopes in Chile, Hawaii, and space-based observatories, a clearer picture began to form. 3I Atlas was unlike anything we had seen. Its brightness fluctuated, its tail shimmered with unexpected intensity, and its coma, the cloud of gas surrounding it, appeared larger than expected for an object of its size. But before anyone could analyze it fully, something extraordinary happened. Almost overnight, the comet brightened. Its magnitude increased exponentially, far faster than any known cometary behavior. What was once a dim speck suddenly glowed with the intensity of a small star, visible even through mid-range amateur telescopes. NASA's early analysis suggested that as the comet neared the inner solar system, it began to rapidly disintegrate. Sunlight striking its fragile interstellar ice caused violent outgassing, erupting jets of vapor and dust that reflected sunlight and gave it an almost explosive brightness. This wasn't just a scientific curiosity. It was a phenomenon unlike anything astronomers had ever observed from an interstellar object. For a brief moment, Comet 3 I Atlas became a cosmic lantern, illuminating the void between worlds. As the data poured in, scientists realized they were witnessing a time capsule from another sun, a piece of matter that had likely been drifting for millions, perhaps billions, of years through the cold darkness between stars. Each molecule, each dust particle, carried the chemical fingerprint of a place far beyond our reach. Studying it was like touching the ashes of another world. To understand the significance of this discovery, you have to imagine the scale of interstellar space. The nearest star to us, Proxima Centauri, is over 4 light years away. That's about 25 trillion miles. Between us and them, there is nothing but emptiness, a cold, silent ocean of dust and radiation. And yet, somehow, this small comet had survived that journey, carrying within it the frozen whispers of another solar system's birth. NASA's teams used every tool at their disposal: the Hubble Space Telescope, the James Webb Space Telescope, and ground-based observatories to analyze the light spectrum coming from 3I Atlas. They wanted to know what it was made of. The findings were fascinating. Unlike typical comets born in our Oort cloud, this one showed unfamiliar chemical ratios. Some of its volatile compounds had never been observed in solar system comets before. That meant it was born under different conditions, maybe around a different type of star, or in a colder, more distant region of its original system. This discovery didn't just reveal a new comet, it opened a window into the diversity of planetary systems across the galaxy. Every solar system forms differently, and comets like this one carry the earliest building blocks of those worlds, the same raw materials that may have seeded planets with water, carbon, and the chemistry of life. To study 3I Atlas was to study another version of our own beginnings, but there was something haunting about it too. Because this comet would never stay. Its path was too steep, its velocity too great. After brushing past our sun, it would head back into interstellar space, fading beyond the range of every telescope on Earth. We would never see it again. For a brief moment in cosmic history, it had passed through our cosmic neighborhood, and then it would vanish forever, a visitor we could never call back. For astronomers, that fleeting nature made it even more precious. Time was running out. They coordinated globally to capture as much data as possible. Observatories in both hemispheres tracked its every movement. Even amateur astronomers pointed their lenses skyward, trying to glimpse this traveler before it disappeared. In a way, the entire planet became united by curiosity, looking up at the same object, knowing that it had come from a place we could only imagine. NASA's researchers published their early findings, describing how the comet's motion confirmed its interstellar origin. It had an eccentricity, a measure of how open its path was greater than 1, meaning it was not gravitationally bound to the Sun. Its speed at perihelion, the point closest to the Sun, exceeded the escape velocity of the solar system by tens of thousands of miles per hour. No known solar comet could achieve such a trajectory. The numbers were conclusive. 3I Atlas was from beyond. For planetary scientists, this was a rare opportunity, a chance to compare materials formed under completely different cosmic conditions. It was like a gift from another universe, even though it came from within our own galaxy. They analyzed how the dust and gas reacted to solar wind, how its tail developed under the sun's pressure, and how its nucleus behaved as it heated. Every frame of data told them more about the chemistry of distant systems, the ice ratios, the presence of carbon monoxide, ammonia, methane, and other volatiles that made this comet so unstable. And yet, for all the data, there was also emotion. Those who gazed at it through the eyepiece spoke of a strange feeling of awe mixed with melancholy. This object had wandered the galaxy for perhaps eons, unseen and untouched, until it briefly crossed our sky. It carried with it the cold silence of interstellar space, a silence older than humanity itself. Watching it brighten and fade was like watching a spark drift across an endless night. NASA scientists couldn't help but feel a sense of connection. Somewhere in another solar system, perhaps another civilization might have once looked up at their own sky and seen this same comet departing from their sun billions of years ago. And now, across the gulf of time and distance, it had reached us. That idea that we were seeing something that had once belonged to another world gave the discovery a human depth. Science met wonder, data met emotion, the coldness of math met the warmth of imagination. As the weeks passed, Comet 3, I-Atlas continued to brighten and then began to disintegrate. Telescopes captured fragments breaking off from its nucleus, each one glowing briefly before fading into the darkness. It was as if the comet was burning its story into our sky, a final act of brilliance before returning to the void. Even as it died, it revealed its secrets. The gases released gave researchers new clues about its internal structure and the environment it had formed in. For NASA and the global scientific community, it wasn't just another discovery. It was a rare alignment of timing, technology, and luck. The right instruments at the right moment pointed in the right direction to capture a fleeting traveler that had crossed the galaxy. Such events remind us of how little we still know and how vast the universe truly is. There are likely countless interstellar objects passing through our system every century, most too small or too dim for us to detect. But every once in a while one reveals itself, bright enough to be seen, long enough to be studied, and mysterious enough to reignite humanity's sense of cosmic wonder. That's what Comet 3, I-Atlas did. It reawakened our imagination. It made us look up again and realize that space is not empty. It's alive with motion, with travelers, with stories older than we can comprehend. It reminded us that we are part of something vast and beautiful, where even the smallest object can carry the memory of stars. In the end, the discovery of Comet 3, I-Atlas, was more than an astronomical event. It was a message that the universe is still full of surprises, that there are still unknown things moving through the dark waiting to be seen. It was proof that our quest to explore, to question, to look beyond is not in vain, because every time we find something like this, we find a piece of ourselves reflected in the infinite. When NASA revealed the discovery, the images captured imaginations around the world. News outlets called it a ghost from another solar system. Scientists described it as a window into alien chemistry. But for those who spend their lives studying the stars, it was something deeper. It was a reminder that the cosmos is still talking to us. We just have to keep listening. And so, as Comet 3, I-Atlas continued its lonely voyage back into the interstellar dark, humanity watched for one last time as it faded from sight. It came quietly, burned brightly, and left us with questions that will echo for generations. We may never know the star it came from or the story of its birth, but we do know this for a moment. We shared the same sky with a traveler from another world. And that, perhaps, is one of the greatest discoveries of all. For weeks, astronomers had been quietly tracking Comet 3, I-Atlas, across the darkness, a dim smudge of light gliding silently against the tapestry of stars. It was faint, almost ghost-like, barely distinguishable from background noise. NAS, as early measurements showed nothing remarkable, a small, cold visitor from interstellar space, another icy body drifting through the void. But then, without warning, everything changed. At first, it was subtle. The comet's brightness increased slightly, enough to make scientists check their calibration. Perhaps a technical glitch, they thought, a misread sensor, but as the hours passed, the light curve continued to climb, steady, consistent, unstoppable. In less than a week, that faint, almost invisible smudge had become a beacon in the sky. It was brightening faster than any model could predict. Something extraordinary was happening. NASA's observatories scrambled to respond. Data from Hawaii's Atlas telescope was quickly verified by independent observations from Chile, Spain, and Japan. Every telescope pointed toward the same coordinates confirmed it. Comet 3, I-Atlas, had suddenly become hundreds of times brighter than expected. It wasn't a trick of the atmosphere, nor a software error. It was real. The universe had just lit a flare. To understand what this meant, you must imagine what happens when a comet approaches the warmth of a star. Comets are made of ancient ice and dust, frozen time capsules from the birth of solar systems. For billions of years, they drift untouched in the deep cold. But when they near a star, heat begins to awaken them. The ices trapped inside, carbon monoxide, ammonia, methane, water begin to vaporize, forming a glowing halo of gas and dust called a coma. It is this halo, illuminated by sunlight, that gives comets their ethereal beauty. But 3, I-Atlas wasn't just awakening. It was erupting. NASA's infrared instruments picked up violent outgassing, sudden jets of vapor shooting from the comet's surface, pushing debris outward into space. Some of these plumes were large enough to alter the comet's rotation slightly, causing it to tumble and shimmer as it moved. Astronomers compared it to a cosmic volcano, an object tearing itself apart in real time. The brightness wasn't from reflected sunlight alone, it was from the comet's own disintegration. In simple terms, Comet 3, I-Atlas, was dying beautifully, violently, and fast. The cause of this sudden transformation fascinated scientists. Because it wasn't just a solar system comet melting under the familiar heat of our sun. This was interstellar material, forged around another star, possibly billions of years ago. Its chemistry was alien, its ice unstable, its structure fragile in ways we had never encountered before. When it came close enough for the sun's rays to touch it, the result was explosive. The comet had spent millions of years traveling through the freezing emptiness between stars, where temperatures hover near absolute zero. In that deep cold, its internal gases were sealed under immense pressure, locked inside crystalline shells. As soon as it met the warmth of our star, the pressure released all at once, like a cosmic time bomb triggered by sunlight. NASA scientists were both thrilled and heartbroken. They knew they were witnessing something that would never happen again. The comet's brightening was a sign that it was unraveling, a fragile relic of another world succumbing to the energy of ours. They had only days, maybe weeks, to capture its data before it broke apart completely. Through the Hubble Space Telescope, images showed the comet glowing an electric green, a color caused by diatomic carbon gas fluorescing in sunlight. Its coma expanded rapidly, stretching across thousands of miles. The tail, a stream of dust and vapor trailing behind, grew longer with every rotation. For a brief time, 3, I-Atlas outshone many of the stars in its region of the sky. Amateur astronomers around the world could now glimpse it through binoculars, unaware that they were witnessing the death throes of a cosmic traveler. But even amid the excitement, a question lingered. Why so fast? Why did this comet brighten so violently compared to others? The models didn't fit. NASA's researchers hypothesized several possibilities. One theory suggested that the comet's nucleus was fractured, allowing sunlight to penetrate deep within and vaporize ices that normally would remain sealed. Another idea proposed that 3I Atlas had an unusually high ratio of volatile gases, materials that evaporate even in the cold of deep space, making it inherently unstable. A third theory was more poetic, that the comet was shedding layers like memories, releasing the chemical history of its parent system into the void as it died. Whatever the cause, the spectacle was breathtaking. Telescopic images revealed the comet's coma pulsing, its brightness flickering as jets of material erupted in bursts. It seemed alive, a living flame in the black sea of nothingness. Astronomers compared it to a heartbeat, the rhythmic dying breath of a celestial traveler. In just a few weeks, it had gone from a faint interstellar ghost to a shining monument of cosmic motion. And then, just as suddenly as it brightened, the fading began. NASA's data showed the light curve flattening, then declining. The once brilliant coma began to fragment. The tail dispersed. Observers reported that the nucleus seemed to split into smaller pieces, a classic sign of structural collapse. The comet had overexerted itself. The rapid brightening was the prelude to destruction. 3I Atlas had burned too brightly, too quickly. It had met the sun's warmth and given everything it had to give, but in that destruction lay its greatest gift. For as it broke apart, it revealed layers of material that had never before been exposed. Pristine interstellar ice, the raw building blocks of another star system. NASA's spectrometers captured readings of exotic compounds that had only been theorized in cosmic chemistry. Each molecule, each dust grain, told a story not of our solar system, but of another one, perhaps orbiting a different type of star in a completely alien sky. The comet was disintegrating, but in doing so, it was unveiling the blueprint of its creation. This was what scientists live for, not just beauty, but revelation. Every second of the comet's breakdown provided data that might help us understand how planetary systems form and evolve across the galaxy. The rapid brightening, while visually stunning, was also a rare laboratory in motion, a real-time experiment in astrophysics conducted by the universe itself. And yet, for those watching the live images, there was an emotional weight that numbers couldn't convey. You could almost feel the story unfolding, a wanderer from another star, silent for eons, igniting for a brief moment of glory before vanishing forever. There was a sense of melancholy in knowing that this was both its arrival and its farewell. It had traveled for countless ages through the cold dark, only to burn out in the warmth of a foreign sun. Like a spark landing on an ocean, it shone, it hissed, and then it was gone. NASA's official statement described the brightening as unprecedented, emphasizing that it gave humanity a unique opportunity to study interstellar material in action. But behind the technical language was something deeper: awe. Even among seasoned scientists, the event stirred something ancient, something emotional. It reminded everyone watching that science isn't just about data. It's about witnessing creation and destruction in their rawest forms, about feeling humbled by forces beyond control or comprehension. Around the world, stargazers gathered to see what they could before the comet disappeared. In rural towns and remote deserts, people pointed their telescopes and cameras toward the night sky, unaware that they were looking at the light of a dying interstellar traveler. For many, it became a symbol of beauty and impermanence, a visual poem written in starlight, reminding humanity of how fleeting even cosmic wonders can be. For the researchers who had tracked it from discovery, the rapid brightening was both a gift and a race against time. They poured through data around the clock, coordinating between observatories and satellites. Each night mattered. Every image, every spectral reading might contain something we had never seen before. The comet was giving away its secrets, but only for a moment. And then it would be gone, beyond the reach of any telescope, fading back into the abyss between stars. When the final images came in, as scientists noticed a haunting sight. The once bright core of 3I Atlas had split into multiple fragments, each dimmer than the last. The brilliant coma had dissipated, the tail was fading, the show was over, but the memory of its light remained etched in images, in data, in the hearts of everyone who had seen it. In cosmic terms, its outburst lasted only an instant, a spark in the grand scale of eternity, but for humanity it was a moment of connection. We had seen something ancient come alive, we had witnessed the death of a traveler from another star. And in that moment, across continents and oceans, we all looked up at the same piece of the universe, humbled and astonished. The brightening of Comet 3I Atlas was more than an astronomical event. It was a lesson about fragility, about impermanence, about how beauty and destruction often arrive hand in hand. It reminded us that even in the coldest reaches of space, there is drama, passion, and poetry. The universe, vast and indifferent, still stages scenes that move the human heart. Long after it faded from view, 3I Atlas continued to inspire. Scientists continued to analyze the fragments of data, building new theories about interstellar matter. Writers and dreamers continued to tell its story, a comet that came from another sun, burned brightly, and was gone. And maybe that's all any of us can do to arrive to shine, to leave something behind in the darkness. Because that's what Comet 3I Atlas did. It came from nowhere, revealed its light, and vanished into forever. But for the brief time it was here, it reminded us of everything we love about the night sky, its mystery, its silence, its endless beauty. It showed us that even across the impossible distances between stars, there are moments when the universe speaks not in words, but in light. When NASA confirmed that Comet 3I Atlas was not bound to our sun, the realization struck with quiet astonishment. We were not looking at something born from our solar system. This was an alien, a visitor from another star, a wanderer forged under a different sun, carrying within its frozen heart the chemistry of another world. And for the first time in history, we had the tools to understand it. Astronomers had long theorized about the existence of interstellar comets. The space between stars is not truly empty, it's a vast sea of dust, gas, and shattered remnants of other solar systems. When planets form around a new star, countless smaller fragments, comets, asteroids, and icy bodies are ejected outward, cast into the void by gravitational chaos. Most drift endlessly, silent and unseen, for millions or even billions of years. Occasionally, one of them will cross paths with another star system, drawn in by gravity for a brief visit before continuing its endless journey. That's what 3I Atlas was, a cosmic exile, born in another system, flung across interstellar space and passing now through ours. But what set it apart was its composition. When NASA and ESA observatories began analyzing its spectrum, the light reflected and emitted by the comet, they found signatures that made scientists pause. The light coming from 3I Atlas didn't match any known patterns seen in solar system comets. There were chemical ratios that simply didn't belong here. In its glowing halo, instruments detected an unusually high concentration of certain volatile compounds, exotic ices, and carbon, bearing molecules rarely found together. The fingerprints of another origin. Every comet is like a time capsule, preserving the ingredients from the era when its system formed. The icy shell of 3I Atlas carried the original dust and frozen gases from its parent star's birth disk, untouched, unchanged, sealed in darkness for eons. When sunlight began to strike it, those materials vaporized, releasing the molecular memories of a world light years away. For NASA's scientists, it was like opening a message written in the language of chemistry, sent across the galaxy long before humans existed. They began to compare the readings, the ratio of carbon monoxide to carbon dioxide, the relative abundance of water ice, the spectral lines of cyanogen gas. Everything told a story, one that didn't quite match the patterns we knew. It appeared that 3I Atlas had formed in a region colder and more distant than our own Oort cloud, perhaps around a dim star or a binary system where temperatures were even lower than those in our solar nursery. The comet's chemistry suggested it was born in the outermost reaches of its home system, far beyond where any planet could have formed in a place of endless frost and frozen shadows. That meant this comet was ancient, older, perhaps, than the Earth itself. While our planet was still molten rock, this small body was already drifting between stars. Over the ages, cosmic radiation had bombarded its surface, altering it molecule by molecule. Yet its inner core remained pristine, a sample of the interstellar medium as it existed billions of years ago. When NASA's instruments detected hydrogen cyanide, ammonia, and traces of methane, they realized they were looking at the same raw materials that give rise to life. In its own distant world, 3I Atlas may have carried the seeds of chemistry that once formed oceans and atmospheres, perhaps even the building blocks of biology. The implications were staggering. If comets like this are common, if every solar system casts away thousands of fragments like 3I Atlas, then the galaxy itself may be constantly exchanging materials. Molecules capable of creating life could be traveling between the stars, scattering like pollen across the cosmic wind. The idea, once only a poetic theory called panspermia, suddenly seemed plausible. Perhaps life in its simplest forms is not confined to any one world, but shared among them, carried by comets like this one. In that sense, 3I Atlas wasn't just a traveler, it was a messenger. NASA, as scientists, understood the weight of that thought. When they looked at its spectral data, they were not merely seeing the chemical breakdown of a comet. They were reading a chapter of galactic history. The ratio of oxygen to carbon told them about the kind of star it once orbited. The isotopic signature of its hydrogen told them about the temperature at which it formed. Even the pattern of dust grains captured in polarized light revealed something about the magnetic fields of its birth region. Piece by piece, they began to reconstruct the story of its origin. Imagine a distant sun, smaller and cooler than ours, surrounded by a swirling disk of gas and rock. Planets forming, colliding, breaking apart. And somewhere on the coldest edge of that system, beyond the reach of light, a small icy fragment condenses, a mixture of water, methane, ammonia, and dust. It remains there for millions of years, orbiting quietly. Then, as the system ages, the dance of gravity begins. A passing planet disturbs its orbit, flinging it outward. The star's pull weakens, the comet escapes. For the first time, it drifts free, a small spark in the endless dark. And so begins its voyage through interstellar space between the stars, across unimaginable distances, carrying within it the signature of its home. That was the journey of Comet 3I Atlas. What made it even more mysterious was how it compared to the two previous interstellar visitors. Oumuamua, discovered in 2017, showed no coma at all. It reflected light but released no gas, behaving more like a rocky fragment or perhaps the core of a shattered world. 2I/Borisov, on the other hand, was more like a normal comet, though its chemistry was slightly different. But 3I Atlas stood apart from both. It was volatile, reactive, and unstable, bursting with energy when sunlight touched it. Some astronomers even speculated that its home system might have had different elemental abundances, a different balance of carbon and oxygen, producing ices more fragile than ours. It was a reminder that not every solar system plays by the same rules. In the laboratories where NASA's data was analyzed, researchers spoke of it with quiet reverence. They weren't just studying an object, they were studying another origin. One scientist described it as the closest thing to touching another star's past. Every reading felt sacred, the temperature of its coma, the wavelength of its emissions, the speed at which its gases expanded. The comet's body was a living record of cosmic history, and for a few short weeks humanity had access to it. There was also something deeply humbling in that realization. The universe is unimaginably vast, and yet, through chance and precision, this small body had come to us. It had crossed the void, untouched by anything for eons, to offer a glimpse into another reality. In its icy shell lay the story of a star we would never see, a system that might no longer even exist. 3. Atlas could have been the last surviving fragment of its home, the final echo of a world long gone. When scientists mapped its trajectory backward through space, they tried to estimate where it might have come from. The path traced to a region in the constellation of Lyra, but the uncertainties were enormous. The comet had been traveling for so long that even the gentle tug of distant stars could have shifted its course. It might have come from a red dwarf system, or the outer arm of the Milky Way, or even farther. The truth was, we might never know. And perhaps that was part of its beauty, that it carried with it a mystery no equation could solve. Still, the day it left behind told enough to change the way we think about the galaxy. It showed that interstellar exchange is real, that the boundary between star systems is not a wall but a bridge. Each comet that escapes its home becomes a thread connecting one system to another, spreading material, memory, and possibility. 3. Atlas was one of those threads, and for a fleeting moment Earth became part of that network, part of a cosmic conversation billions of years in the making. As the comet continued its journey, its light began to fade again. The bright green glow dimmed to a pale gray, the gases dispersed, and the tail stretched thinner until it dissolved into the background stars. Yet in its wake, it left behind something profound, not just data, but perspective. It reminded humanity that our solar system is not isolated. We are part of a galactic ecosystem, a flow of dust, ice, and energy shared between stars. The materials that built our planets may once have belonged to other worlds, and the fragments we lose now may one day drift through another sky. That realization changes everything. It means that in the grand story of creation, nothing truly belongs to one place. Matter travels, stories travel, the universe recycles itself endlessly, reshaping and redistributing the elements of existence. Comet 3, Atlas was proof of that cosmic continuity, proof that across unimaginable distances, the same chemistry, the same physics, the same longing for life are at work. When NASA released the final analysis, the language was careful and scientific, but between the lines you could feel the awe. The comet's spectral data revealed molecular ratios unseen in any known comet from our system. Its isotopic patterns hinted at an origin environment colder than the outer reaches of our own Oort cloud. The conclusion was undeniable. 3. Atlas was made of material alien to our sun, a relic from another sun's creation. And yet, despite its strangeness, there was something familiar about it. The gases it released, water, carbon monoxide, cyanide, were the same ingredients we know as the building blocks of life. That paradox, that something alien could also be so familiar, touched something deeply human. It reminded us that the universe, vast and distant as it is, operates under a shared logic. The same cosmic laws that shaped our Earth shaped that faraway system too. We are made of the same stardust. As Comet 3, Atlas drifted farther from the sun, fading into the black. It left behind only memories and data. But those were enough. In its light, we saw a reflection of our own origins, a reminder that even we, on our small blue planet, are travelers in a sense. The atoms in our bodies were forged in ancient stars, scattered, gathered, and reshaped. We are interstellar material too, temporarily gathered into form. And so, when we looked at 3I Atlas, we weren't just observing something foreign. We were looking into a mirror, one held up by the universe itself, reminding us that we are part of the same cosmic story. That the dust of alien suns flows through us, that the boundaries between worlds are illusions, and that the journey of this comet was, in some strange way, our own. It came from another star, it burned in our sky, and then it was gone. But in its brief encounter with us, it told a story older than humanity, a story of birth, exile, and return. The story of how the universe keeps moving, keeps creating, keeps connecting everything to everything else. That is the legacy of Comet 3I Atlas, a messenger from the unknown, reminding us that we too are made of wandering light. When NASA turned its instruments toward Comet 3I Atlas, it wasn't merely to study another piece of cosmic ice. It was to witness in real time the unfolding of an interstellar mystery. What began as a faint blur moving slowly through the constellation of Ursa Major transformed into a breathtaking display of celestial theater, a green flame igniting against the velvet black of space. To the naked eye it was subtle. To NASA's telescopes it was an unfolding revelation, a story told in wavelengths of light invisible to human eyes. The first to detect its peculiar brightness variations were the astronomers using NASA as NEOI's mission. As the comet approached the sun, instruments registered a dramatic surge in luminosity far greater than what a comet of its size should have produced. In days, its magnitude changed as if something within it had awakened. It was not a gradual warming or a predictable outgassing, it was a flare of life. The team watched in silence as data streamed in infrared readings, thermal fluxes, ultraviolet spikes. Each frame captured a comet not just reflecting sunlight, but reacting to it almost violently. NASA's Hubble Space Telescope followed next, locking its gaze onto the bright nucleus. At that scale, the comet's coma, the glowing cloud surrounding its icy core, was immense. It shimmered with colors hinting at exotic molecules, cyanogen gas glowing a ghostly blue, ionized carbon producing green auroras, dust scattering sunlight into a halo. What they saw was not just beauty, it was chemistry in motion. Every hue, every flicker was a code to be deciphered. Spectrographs on Hubble and ground-based observatories like the Subaru telescope began to break that light apart. The results astonished even veteran scientists. The ratio of carbon monoxide to water vapor was far higher than typical comets of our solar system. Certain volatile compounds, such as diatomic carbon, appeared in unusual abundance, suggesting a much colder birthplace, possibly from the outermost regions of another star system. To NASA, this was like finding an ancient fossil written in ice, whispering of conditions that existed billions of years ago, light years away. The Swift Observatory then recorded ultraviolet emissions, the spectral fingerprint of freshly exposed ices being bombarded by solar radiation. That meant 3I Atlas was highly unstable, shedding material faster than predicted. In fact, NASA scientists theorized that the comet's structure might be unusually fragile, more porous and brittle than the comets we know. Every rotation, every moment of heating, caused internal stresses to build until, eventually, they fractured its core. But before that dramatic moment came, NASA captured everything. The Solar and Heliospheric Observatory SOHO, designed primarily to study the sun, caught the comet as it moved closer, its tail stretching across millions of kilometers. Cameras detected jets bursting from the nucleus, ejecting gas and dust at speeds of hundreds of meters per second. In those chaotic plumes, the comet revealed its soul. NASA's scientists compared it to a living entity undergoing transformation. It's like watching an ancient traveler finally breathe, one astrophysicist remarked. The data suggested that as sunlight penetrated deeper into its nucleus, layers of alien ices untouched for eons began to vaporize. The comet's brightening wasn't merely reflection, it was chemical release. Molecules imprisoned since before Earth's birth were being freed into the void, glowing as they interacted with solar energy. The sheer amount of material being released surprised even the experts. Normally, a comet's activity increases gradually as it warms. But 3I Atlas flared explosively, almost like a star in miniature. NASA's Jet Propulsion Laboratory modeled the thermal dynamics of its nucleus and discovered something extraordinary. The comet's interior appeared to be unusually rich in supervolatile compound substances that vaporize at very low temperatures, such as carbon monoxide and methane. In the frigid conditions of interstellar space, these ices could have remained stable for billions of years, but under our sun's heat, they ignited with fury. Every instrument NASA deployed from infrared to ultraviolet confirmed the same story. The comet's activity defied standard models. It was as though its core had been built under physical conditions no longer found anywhere nearby. This wasn't just a visitor from another star, it was a survivor of a time and place we could only imagine. As the comet continued to brighten, NASA's Deep Space Network tracked its motion with precise radar reflections. They calculated its trajectory, measuring its eccentricity, how open its orbit was. The results left no doubt. Its path was hyperbolic, meaning it would never return. The sun's gravity would curve its course, but could not hold it. 3I Atlas was just passing through, a one-time guest, never to be seen again. That realization added a quiet melancholy to the excitement. Every image, every measurement became sacred, because once it left, it would vanish forever into the deep. NASA's data archive filled rapidly. Each instrument, Hubble, Neowise, SOHO, and Swift, contributed to a mosaic of information that would take years to fully interpret. But even in the first analyses, patterns emerged that told a deeper story. The isotopic signatures of hydrogen within its water showed subtle deviations from those found in solar system comets. That tiny difference in the ratio of deuterium to hydrogen meant it formed under different stellar conditions, at a temperature distinct from any found in our sun's protoplanetary disk. It was as if the universe had given us a small clue about how differently worlds could form. At NASA's Goddard Space Flight Center, the data was plotted, compared, and debated. Some scientists theorized that the comet's composition indicated a star smaller and cooler than our sun, a red dwarf system. Others argued it might have come from the outskirts of a binary system, where gravitational perturbations could have easily ejected it into interstellar space. No matter the origin, all agreed on one point. 3I Atlas expanded the definition of what a comet could be. To the public, it was a spectacular sight. To NASA, it was a scientific milestone, the third confirmed interstellar object ever detected. Unlike Oumuamua, which reflected light but released no visible gases, 3I Atlas was alive with motion and color. It gave researchers their first detailed look at what happens when alien ice meets our sun's fire. That contrast, the foreign and the familiar, fascinated everyone. As days passed, NASA's instruments began to pick up strange fluctuations in brightness. The comet seemed to pulse, brightening and dimming rhythmically. It was as if it were breathing. Analysts proposed that it might be rotating, exposing different active regions as it spun. Others suspected that it was breaking apart internally, fractures forming deep within, unseen but inevitable. Then came the moment NASA both anticipated and dreaded. The comet began to fragment. Observations from Hubble confirmed what the data hinted at. Multiple bright knots of light appeared where once there had been one. Its nucleus had split into several pieces, each trailing dust and vapor. For the scientists watching, it was a heartbreak and a gift all at once. They were witnessing the death of a visitor from another star, but also its revelation. When it fractured, it exposed its inner core, releasing material that had been shielded from radiation since the dawn of its existence. Instruments recorded a sudden spike in rare gases, confirming that beneath the weathered crust lay pristine interstellar ice. For NASA, that was the most significant discovery of all. They were observing, for the first time, the internal chemistry of an interstellar body material that had never before interacted with our sun. It was like cracking open a relic from the beginning of time. The gases it released told stories older than our galaxy's spiral arms. They revealed that the building blocks of life, organic molecules like formaldehyde and methane, exist even in the coldest, most distant reaches of the cosmos. Life, it seemed, had chemical roots far beyond any one planet or system. This revelation rippled through NASA's astrobiology division. The idea that interstellar comets could carry probiotic compounds gave new weight to the theory that life's ingredients are universal. Perhaps the same materials that seeded Earth were once carried by travelers like 3I Atlas. The comet's outgassing showed the same molecules that form amino acids, the foundation of life, could easily survive interstellar travel. That meant the galaxy itself might be a cradle of potential, spreading the chemistry of life from system to system. As data continued to pour in, NASA's computer models simulated the comet's journey. Some traced it back hundreds of thousands of years, trying to guess from which star it had been flung. Others projected its future path, showing that after passing the sun, it would head toward the outer regions of the galaxy, never to return. Somewhere, millions of years from now, it would drift into another system, perhaps to be seen by another civilization if one exists, and they too might study it with wonder. There was something profoundly poetic about that. A traveler from a distant sun, visiting ours for a brief moment, leaving behind whispers of its story before continuing on its way. It was as if the universe itself had orchestrated a meeting between strangers, two civilizations separated by light years, connected only through science and curiosity. In mission briefings, NASA's scientists often spoke not just with data but with awe. They described how humbling it was to realize that this fragile, icy object had survived eons of radiation, collisions, and darkness to reach us. Against impossible odds, it had crossed the void, carrying the frozen memories of another world. Every molecule in its tail, every photon reflecting off its surface, was a message written in the universal language of physics, a reminder that the cosmos is not a collection of isolated systems, but a living network of exchange and continuity. The legacy of NASA's observations would go far beyond the comet's brief visit. The data gathered from 3I Atlas would redefine models of interstellar material, influence future missions, and shape our understanding of planetary formation. It would guide the design of next-generation telescopes like the Nancy Grace Roman Space Telescope and the LUVOIR mission, instruments capable of detecting faint interstellar travelers long before they reach the sun. In essence, 3I Atlas had opened a new chapter in cosmic exploration, one that blurred the line between astronomy and archaeology. Even after the comet's fragments faded from view, NASA's archives continued to glow with its echoes. The infrared maps, spectral graphs, and chemical breakdowns remained silent records of a celestial encounter that may never happen again in our lifetimes. For those who studied them, each curve of data carried emotion. They weren't just studying a phenomenon, they were bearing witness to a once-in-eternity event. In the end, Comet 3I Atlas taught us that science is not just about measurement, it's about meaning. The numbers it gave us, the equations it inspired, all point to one truth, that the universe is more connected, more dynamic, and more generous than we once believed. Every discovery like this reminds humanity of its place, small, fragile, yet capable of understanding the infinite. NASA's observations were not just scientific achievements, they were human achievements. They were acts of curiosity, of longing, of reaching beyond what we can touch. Through their telescopes, scientists saw not just a comet, but the reflection of our own desire to know where we come from and where we are going. And so, as the last traces of 3I Atlas faded into the depths of space, NASA's data told a final story that even the briefest encounters can change everything, that a fragment of ice from another sun can remind us that the same forces shaping the cosmos also shape us. That to study the stars is to study ourselves. It came, it burned bright, and it broke apart, but in doing so, it illuminated truths that will guide generations of explorers yet to come. Its legacy endures, written not just in NASA's archives, but in the expanding imagination of humankind. At first, it seemed like Comet 3I Atlas was becoming a miracle in motion, a frozen visitor from another star blazing brighter every day, almost as if alive. Astronomers across the world spoke of it as a beacon, a sign of something extraordinary. But then, without warning, the miracle began to unravel. The light that had grown with such promise flickered, faltered, and began to fracture. What NASA had called one of the most brilliant interstellar visitors ever observed started to die before it reached its peak. It began subtly, almost imperceptibly. Small variations in the comet's brightness, tiny dips that didn't match its predicted curve. The instruments at NASA's Jet Propulsion Laboratory noticed them first. At that time, the comet was still weeks away from its closest approach to the Sun, and its luminosity should have been increasing smoothly. But instead of a steady rise, there came sudden fluctuations, bright one night, dimmer the next. Something was happening deep inside that fragile nucleus, something that light alone could not explain. Then came the images from the Hubble Space Telescope. Where there should have been a single point of light, the solid, frozen core of the comet, there appeared a strange smearing, a distortion as if the heart of the object had stretched. When as image analysts enhanced the contrast, they saw it clearly. The nucleus had broken apart. 3, maybe 4 distinct fragments, all following the same trajectory, drifting apart at slow but irreversible speeds. The comet was tearing itself to pieces. For days, scientists tried to make sense of what they were seeing. Why would a comet that had survived the brutal cold of interstellar space for millions of years suddenly shatter now? It had crossed unimaginable distances, endured cosmic radiation, micrometeoroid impacts, and the relentless vacuum of deep space, yet it broke apart just as it neared the warmth of a new sun. The mystery was not just in its death, but in its timing. NASA's first theory was simple: sunlight. As the comet approached the sun, temperatures on its surface rose dramatically. Layers of ancient ice, some likely composed of volatile compounds like carbon monoxide and nitrogen, began to sublimate rapidly. This process, where solid ice turns directly into gas, created intense jets that burst through the surface. These outgassing jets act like thrusters, pushing the comet unpredictably, spinning it faster, straining its structure. Eventually, the pressure can exceed the comet's ability to hold itself together, but in 3I Atlas's case, the breakup was unusually early, far before it reached the kind of heat that destroys most comets. That meant there had to be more at work than just sunlight. The next clue came from spectroscopy, the analysis of its light spectrum. NASA's observatories detected a strange pattern, an unusually high ratio of certain volatiles that evaporate at extremely low temperatures. That meant parts of the comet's interior were chemically unstable, possibly containing pockets of trapped gas or frozen compounds that expand violently when warmed. These could have acted like time bombs, detonating from within. In essence, the comet may have been hollow, a fragile lattice of dust and ice that simply couldn't survive the awakening heat. But there was another, deeper mystery, one that made scientists stop and question their assumptions about interstellar bodies altogether. When 3I Atlas disintegrated, the brightness didn't decrease as expected. Instead, for a short while, it increased. As it broke apart, its fragments exposed more surface area to the sun, releasing vast plumes of gas and dust. For a moment it glowed brighter than before, as if in a final burst of defiance. Some astronomers called it the comet's last breath, a cosmic swan song, the blaze before silence. NASA's astrophysicists began running simulations, trying to replicate the breakup using the laws of thermodynamics and structural stress. The models showed that as the comet spun, jets of vapor could have caused rotational acceleration. If its spin increased just enough, centrifugal forces might have torn it apart, piece by piece. In space, such events are almost poetic in their inevitability, a slow dance toward destruction governed by the same physical laws that hold galaxies together. Yet there was something profoundly moving about watching it unfold in real time. The images from Hubble showed fragments trailing thin, glowing tails, each a ghost of the original comet. They moved gracefully through the blackness, like sparks drifting from a dying flame. And behind the data and graphs, there was emotion, a quiet sadness among the scientists who had followed it since its discovery. They had come to see it as more than an object. It was a traveler, an emissary from another star, carrying within it the chemistry of a world we would never know. And now, before it could share all its secrets, it was gone. NASA's Solar and Heliospheric Observatory SOHO confirmed the final act. As the comet neared its closest point to the sun, the fragments faded rapidly. The coma dispersed, the tail thinned, and soon the once brilliant traveler was nothing but dust and vapor. In a matter of days, what had been a beacon of interstellar mystery dissolved into invisibility. The universe had reclaimed it, but even in death, 3I Atlas continued to teach. The fragments it left behind allowed scientists to study how interstellar materials respond to stellar heat, knowledge that would prove vital for future missions. NASA's thermal models revealed that the comet's density was astonishingly low, more like compressed snow than solid rock. This confirmed that it was never built to last. Its structure had survived only because it had spent its life in the cold void. The warmth of a star, any star, was always destined to be its undoing. That insight carried deeper meaning. In a sense, the comet's demise wasn't a failure of strength, it was the fulfillment of its design. It had been formed in darkness, and in light it revealed itself completely. When it broke apart, it released everything it had: its molecules, its secrets, its history. The universe, vast and patient, had waited billions of years for that moment, and for a few short weeks humanity bore witness. NASA's scientists described it almost with reverence. It was as if the comet sacrificed itself to tell us what it was made of. One researcher said during a briefing, "The disintegration, tragic as it seemed, allowed instruments to analyze materials from the comet's core matter that had been sealed off from the cosmos since its formation. In its final moments, 3I Atlas gave up its oldest truths. Among those truths was the discovery that its dust contained complex organic compounds, carbon, rich molecules that could form the precursors of amino acids. These were not simple ices, they were chemistry in its most creative form. It was proof that the universe builds the ingredients for life everywhere, even in the frozen ruins between the stars. That revelation, hidden within the comet's disintegration, became one of the most profound findings of the mission. But beyond science, there was symbolism. The comet's story mirrored the story of existence itself: birth from chaos, a brief flare of light, an eventual return to the darkness that made it. Its destruction wasn't meaningless. It was transformation. Its pieces scattered through the solar system, carried by solar wind, joining the endless dust that drifts between worlds. In some small way, 3I Atlas became part of us, part of the cosmic material that forms everything from planets to people. For NASA, the data from its disintegration offered a final chapter. The fragments moved in predictable arcs, each fading at its own pace. Some scientists estimated that fine dust from the comet might eventually reach the edges of our solar system, merging with the Oort cloud, a poetic ending for an interstellar traveler. It came from another system, and now its remnants would rest among the frozen sentinels at the farthest reaches of ours. In press conferences, when NASA shared the last images, there was a kind of quiet mourning. You could see it in the eyes of the astronomers, that mix of loss and awe that only space can evoke. They had watched something older than humanity live and die in the span of months. They had seen an alien artifact crumble in sunlight, and in its collapse reveal the most intimate details of creation. Few scientific discoveries carry such emotional gravity. The comet's sudden disintegration became a subject of fascination for theorists. Some speculated that interstellar radiation had weakened its structure over time, turning its once solid interior into a fragile sponge of microfractures. Others suggested that during its formation it may have incorporated exotic materials, perhaps metallic grains or carbon chains that made it prone to thermal stress. Each theory was a new attempt to understand not just how it died, but why. And yet, in a way, the why didn't matter. What mattered was what it revealed in dying. It showed that interstellar visitors are not eternal wanderers. They are transient, delicate, and deeply alive in their own way. Their existence reminds us that everything in the universe, even the most ancient, is impermanent. Comet 3I Atlas lived its life in darkness and perished in light, and in that cycle lay the essence of cosmic truth. Creation and destruction are not opposites, they are partners. When the final analysis came in, NASA published its findings with characteristic restraint. The report spoke of structural instability, volatile depletion, and thermal fragmentation. But between those technical phrases, there was something unspoken, the acknowledgement that what they had witnessed was both scientific and poetic. The comet had come from beyond the reach of any telescope, traveled for eons through the emptiness, only to shatter under the gaze of humanity's instruments. It was almost as if it had waited for us to be here, to see it, to understand it. In classrooms and observatories around the world, the story of 3I Atlas became more than data. It became a reminder of fragility. The comet's collapse symbolized the tension between endurance and vulnerability, the paradox of all existence. Even the most ancient traveler, built from the bones of stars, can be undone by a little warmth, a touch of light, and yet, what a beautiful undoing it was! Its tail shimmered one last time before fading into invisibility, scattering molecules that may someday fall upon another world. Perhaps far in the future, those particles will drift into a new system, a young planet's atmosphere, where heat and chemistry might spark something alive. In that sense, 3I Atlas didn't die, it evolved. It continued the story that began in its own forgotten system, carrying it forward through dust and time. The mystery of its disintegration will never be fully solved. No telescope could capture every detail of that quiet catastrophe. But in the fragments of light, in the spectral data, in the collective memory of those who studied it, the comet remains eternal. It reminds us that the universe does not promise permanence, only wonder. And maybe that's the lesson 3I Atlas came to teach, that beauty often burns brightest just before it fades, that even in destruction there is revelation, that to break apart is not to vanish, but to become part of something greater. The comet's sudden death wasn't an end, it was a message written in light, a fleeting reminder that everything in the cosmos, from stars to souls, is in motion, destined to transform. It came as a visitor, left as dust, and in its brief passage through our skies it taught us that nothing truly disappears. Everything simply becomes part of the next chapter in the story of creation. When we look up into the night sky, we often see stillness, stars glimmering silently, galaxies painted faintly across the darkness, and the occasional meteor slicing through the void. But beneath that apparent stillness lies a restless universe, an ocean of motion and energy, where worlds are born and destroyed, where matter drifts endlessly through the cold corridors of space. And every so often, something from that deep cosmic sea enters our field of vision. A visitor, a messenger, a symbol of connection between distant worlds. Comet 3I Atlas was one of those messengers. Its brief journey through our solar system was not merely a scientific event. It was a profound reminder of our place in the cosmos and of the infinite stories still waiting to be told beyond the reach of our sun. For most people, a comet is just a streak of light, a beautiful distraction in the sky. But for scientists, philosophers, and dreamers, comets carry meaning. They are relics from the dawn of creation, frozen time capsules of the elements that once built stars, planets, and possibly even life itself. When NASA revealed the sudden brightening of Comet 3I Atlas, it wasn't just the light that captured our attention. It was the story behind that light, a story billions of years old, carried across unimaginable distances, finally arriving at our doorstep. It was as if the universe whispered, "Look at me, remember how vast I am, remember how connected you are to everything out here." The rapid brightening of Comet 3I Atlas sparked awe not only among astronomers but also among people around the world who followed its journey. In that surge of light, many saw a metaphor for life itself, something small, distant, and forgotten suddenly finding the power to shine with unexpected brilliance. Perhaps it's human nature to find meaning in the stars. We've always looked to the heavens for signs, for stories, for hope, and this comet gave us a reason to do so again. It reminded us that even in the emptiness of space, there is movement, purpose, and beauty beyond measure. But the comet's visit also reminded us of something deeper, our longing for connection. This piece of ice and rock came from another star system, traveling alone through the interstellar void for countless millennia. It crossed light, years of emptiness, never once slowing, never once turning back. Then, by cosmic coincidence, it entered our solar system and for a fleeting moment became visible to the eyes of humankind. That momentary intersection between something alien and our world was symbolic of humanity's place in the universe. We too are travelers, moving through time, seeking meaning and connection. The comet's brief brilliance was like a reflection of our own journey, fleeting yet magnificent. To NASA and to the scientific community, 3I Atlas represented a golden opportunity to study something that had never belonged here. Every data point, every spectral line, every photograph was a chance to understand what exists beyond our own star. What materials form in alien systems? How do they react to sunlight? How do they compare to the comets born near our own sun billions of years ago? The answers to these questions may reveal how unique, or how common our solar system really is. And that's the beauty of cosmic discovery. It always begins with a question and ends with 1,000 more. When scientists examined the spectral signature of Comet 3I Atlas, they found subtle differences from the comets that orbit our sun. Ratios of carbon, oxygen, and volatile compounds hinted at a chemical makeup shaped by another star's light and another world's beginning. In a sense, when we looked at that comet, we were seeing the fingerprints of another sun, another dawn. And that realization, knowing that material from a foreign star system was glowing in our skies, gave humanity a rare, almost spiritual feeling of connection with the cosmos. We were no longer observers of the universe. We were participants in its grand exchange. There's something profoundly humbling in that realization. For centuries, we've believed ourselves to be the center of creation, the masters of our little planet, but each new discovery, each new interstellar visitor, reminds us that we are part of something infinitely larger. Comet 3I Atlas's journey was a gentle but powerful reminder that the universe does not revolve around us. We are simply one chapter in its eternal story, yet that doesn't make us insignificant. If anything, it makes our existence even more miraculous. In a universe of infinite distances and incomprehensible time, we are aware. We can observe, feel wonder, and even love what we do not yet understand. For the philosophers and storytellers of the world, 3I Atlas's passing was poetic. A visitor from beyond, shining briefly, and then vanishing into darkness, it mirrors our own lives. We too appear for a moment in the vastness of time, burn brightly with passion and discovery, and then fade away. But like the comet, our light, however brief, can inspire others. Every act of exploration, every discovery, every dream adds to the collective glow of human existence. NASA's mission at its heart has always been about more than science. It's about curiosity, courage, and the relentless desire to know what lies beyond. The brightening of 3I Atlas was not just data. It was emotion, wonder, and human spirit translated into science. In that light, we saw proof that the universe is alive with motion and surprise. It reminded us that no matter how much we think we know, the cosmos still holds mysteries that can make even the most experienced astronomer pause in awe. And yet, even as we study these wonders, we can't help but feel a tinge of sadness. Because we know that 3I Atlas will never return. Its orbit is hyperbolic, meaning it will continue out of the solar system, back into the endless dark between the stars. Humanity was lucky to witness it, to study it, to capture its brilliance for a moment. But like a traveler passing through a distant village, it will be gone before we even finish waving goodbye. Still, the data, the images, the wonder, it all stays with us. The memory of its passage will linger in our science, in our imagination, and in our stories. Comet 3, Atlas showed us that the universe communicates in light, motion, and silence. It doesn't need words. Its messages come in the form of phenomenal events that remind us that everything is connected. Somewhere, billions of miles away, another comet might now be leaving another star system, beginning a journey that will take millennia to complete, perhaps to one day pass near another inhabited world. Maybe they too will look up and wonder as we did. When we think of cosmic discovery, we often think of telescopes and equations, but the truth is, discovery begins in the heart. It starts with curiosity, with a human looking up and asking, what's out there? Every generation has its moment of revelation, and for ours, comets like 3I Atlas are among those moments. They remind us that the universe is not static or silent, it's alive, evolving, breathing. Its mysteries are endless, and every brightening, every flicker of light across the black canvas of space is an invitation to keep seeking. And so, as Comet 3I Atlas fades into the darkness beyond the sun, its message remains: never stop exploring. Never stop wondering, because every time we reach outward, we also discover something within ourselves. The same curiosity that sends spacecraft to Mars, that peers through the James Webb Space Telescope, that studies distant stars, it all comes from the same spark that once looked up at a night sky and dreamed. Perhaps that's what this interstellar comet truly represented, not just an object of science, but a mirror held up to humanity. It reflected our longing to understand, our courage to explore, and our belief that even in a universe so vast, meaning can be found in the smallest of lights. For in the end, that's what we are, a species made of stardust, guided by wonder, forever reaching for the next glimmer on the horizon. As it drifts away into the dark, Comet 3I Atlas takes nothing from us. It leaves us richer. Richer in knowledge, in humility, and in perspective. It reminds us that life itself is a fleeting brightness against the backdrop of eternity, and that the true beauty of existence lies not in permanence, but in the courage to shine while we can. And somewhere, in the silence between stars, that comet continues its endless journey, still glowing faintly, still carrying the story of its brief meeting with a small blue world where creatures dared to look up and wonder.